friends. This video is going to be a method of solving equations that have fractions in them in sort of a really mathematical kind of way. We're going to use some of the properties that we know about equations, right? That if I do something to one side, I do something to the other side, but I can keep my equation in balance. We're going to use that concept to play a kind of sneaky trick on some of these fractions. And it's a really neat way to think about equations. And so if you were looking for ideas about what the next sort of topic might be in solving equations and what the next challenge might be, this video is going to sort of take you in that direction. So let's take a look at this like neat little tool that we can use, and it's called clearing fractions. Okay. So we sometimes might get problems that are like this, that have lots of lovely fractions in them, right? And fractions are great. But sometimes people don't like to add and subtract them because you have to find the least common denominator, and then sometimes we make mistakes. And so this is a method to sort of clean up some of that work. Okay, so the first thing that we're going to do is always check if there's anything to distribute in your problem, because that could change the way the problem looks. So we'll look at an example like that in a second. But here there's nothing to distribute, so I can jump straight into the second part of this problem, which is finding a least common denominator. Now here's the thing, it's got to be the least common denominator for every single fraction in the problem. So this denominator, and this denominator all need to divide evenly into whatever number I'm going to use. So I need a number that is divisible by 12, is divisible by 3, and is also divisible by 2. Have you figured it out yet, what our least common denominator is going to be? I think it's going to be 12 too. So our least common denominator here is going to be 12. And so here's what I'm going to do with that. I would like to figure out some number, this 12, that if I were to multiply 7/12 by 12, the 12s, right, would cancel out. Well, so let's just think about that for a second, right? If I multiplied 7/12 by 12 over 1, those 12s will cancel out. I'll get 7 over 1 or just 7. If I multiply 12 by the other fraction, so let's say the second fraction, 12 by 1/3, this is going to cancel too, because 3 we said also would go into 12. So 3 would cancel down to 1, 12 would cancel down to 4. So that's going to give me 4. Looking at that last fraction, 12 times 5/2, right? The 2 will cancel with the 12 because we knew 2 would go into 12 as well. And 6 times 5 is 30. So the reason that we've chosen the least common denominator is because it is a multiple that when I multiply it by all the fractions, any of the denominators in the problem will cancel out. We'll simplify down to 1. So here's how we're going to use this little strategy, this little tool. I'm going to take this whole equation and I'm going to multiply the left-hand side by 12 over 1. I'm just going to rewrite this problem here. So negative 5/2 x plus 1/3 x equals, and then I'm going to multiply, I'm going to take this whole right-hand side of the equation, 7/12 minus x, and I'm going to multiply this side. Oh, I made that blue on the other side. Okay. And I'm going to multiply that side also by 12 over 1, because this is an equation, right? I've got to keep myself in balance. If I multiply one side by 12, I have to multiply the other side by 12. So now here's what I'm going to do. I'm going to distribute this 12 to the first term. So 12 times negative 5/2, well, we already did the 12 times 5/2 over here. But again, the 2 would cross cancel with the 12, and so that would give me 6. 6 times negative 5 is negative 6 times negative 5 is negative 30x. And then I'm going to distribute and multiply the 12 by the 1/3 x. So now the 3 and the 12 would cancel 1 and 4. And so that would give us positive 4x. Here's a little tip. Don't cancel the distribute. Don't cancel this one here. Do it off on the side in scratch work, because if you cancel it here, you might forget that you are still multiplying the second term by the whole 12. You're not multiplying it by whatever's left over after you multiplied it by the first one. Okay. And so that's then equal to, now I'm going to do the same thing on this side. I'm going to multiply both of these by 12. So 7/12 times 12 is 7. And negative x times 12 is negative 12x. Well, hey, look at that. There are no more fractions. Notice that I did this even before I combined these like terms, so I didn't have to bother to find the denominator for those and combine them. It just sort of saves us a step. So now I can go ahead and I can just combine my like terms, and negative 30x plus 4x is negative 26x is equal to 7 minus 12x. And so now I will move this 12x to the other side. I'll add 12x, I'll add 12x, and I'm going to get negative 14x is equal to 7. And so dividing both sides by negative 14, x is equal to negative 1/2. And there is my solution. Okay. Let's take a look at one more sort of twist on this. And this next problem is going to be one where we do have to distribute. Okay, so just remembering our steps here, I'm just going to copy them and bring them along. So just remembering our steps here. Oops. Okay. We're going to distribute first if we can, because that might change the denominator, and so we will need to make sure that we're using the least common denominator. But if the denominator changes, then it could get complicated. Okay, so first thing we're going to do is here we have an opportunity to distribute, so we're going to go ahead and do that. So negative 1/2 times positive 1/2, negative 1 times 1 is negative 1. 2 times 2 is 4, so that's negative 1/4 p. Then I'm going to multiply negative 1/2 times positive 1/3. So negative 1 times positive 1 is negative 1. And 2 times 3 is 6. And that's equal now to 2p minus 6 1/6. Now, I need to be able to find the least common denominator so that I can multiply it. So I need to look at every single denominator that I've got going on here. There's a denominator, there's a denominator, and here's a denominator. And be careful because this denominator is in a mixed number, in order to multiply by something, I'm probably going to want to change that up. So that might be feels like my next step. But let's find this least common denominator first. So 4 and 6, well, 24, but there might be a smaller one. And the smaller it is, the easier all the numbers are. So you might notice that there is actually a smaller number, and maybe you've already noticed that it's 12. Okay, so here's what I'm going to do. I'm going to do 12 over 1, and I'm going to distribute that into negative 1/4 p minus 1/6. And then on the right-hand side, I'm going to do the same thing. I'm going to multiply 12 over 1 times 2p minus, I'm going to change this into an improper fraction so that I can multiply it by 12. So 6 times 6 is 36, plus 1 is 37/6. And so now I'm going to distribute these 12. I'm going to come over here and just do a little bit of scratch work. 12 over 1 times negative 1 over 4, that's going to cancel. And so that's negative 3. So that's negative 3p. And I'm going to multiply the 12 times negative 1/6. So 12 over 1 times negative 1 over 6. Those cancel. And I've got negative 2. And then on this side, I'm going to do 12 times 2p. I think I can do that one. That's 24p. And then this next one I'm going to write out too. So we've got 12 over 1 times negative 37 over 6. That cancels, that cancels. That's 2. 2 times negative 37. Okay, 2 times 30 is 60. 2 times 7 is 14. 60 plus 14 looks like 74 to me. So negative 74. Okay. So let's see now what I can do. So let's get all of our p's together. So now I might just add the 3 p's on this side, right? But now it's a little bit easier because I'm not worried about fractions and denominators and everything. So negative 2 is equal to 27p minus 7. Let's try that 7 again. 74. And then let's add 74 to both sides. And so we get 72 is equal to 27p. And so I'm going to divide both sides by 27. I'm going to come up here because I sort of ran out of room. So 72 over 27 is equal to p. I wonder if that's simplifiable at all. Let's see, 7 plus 2 is 9, and 2 plus 7 is 9, so they both must be divisible by 9. So I can simplify this top one by 9, and that would give me 8. And if I simplify this one by 9, it would give me 3. And so p is equal to 8/3. Okay, so that is the method of clearing fractions. I hope you enjoy.